couple of years ago, if you wanted the game at 4K, there was only one solution: buy the biggest, most expensive GPU you could afford. But with AI now doing more of the work every year, we might be heading toward a future where you don't actually need a high-end GPU to get a high-end experience. For most of PC gaming history, graphics performance scaled in a simple way. Higher resolution means more pixels. More pixels means more work for the graphics card. If your frame rate was too low, there was only one real fix: get a faster graphics card. That's why high-end GPUs existed, not to be efficient, but to brute force more pixels, bigger chip, more cores, more power draw. Essentially just raw hardware muscle. But modern graphics cards do not rely purely on brute force anymore. Instead of rendering every single pixel the traditional way, they're starting to let AI handle part of the job. Technologies like DLSS, FSR, and XeSS render the game at a lower internal resolution, then use trained models to reconstruct the image so it looks like a higher resolution. Basically, upscaling, the same way as consoles. And then there's frame generation, where the GPU creates entirely new frames between the real ones. So instead of doubling the workload to double performance, GPUs are getting smarter about how they create performance in the first place. This is where things start to change for regular gamers. In the past, a big performance jump usually meant jumping to a much more expensive GPU tier. Now, a mid-range card with strong upscaling and frame generation can sometimes deliver performance that used to require a flagship GPU. Not because it is more powerful, but because it's doing less traditional work and letting AI fill in the gaps. We're starting to see graphic cards that would have been considered 1440p cards pushing into smooth, visually convincing 4K experiences in many modern games. And that is starting to blur the line between what mid-range and high-end even mean. Now, this doesn't suddenly mean high-end GPUs suddenly don't matter. If you want native 4K with everything maxed out, no upscaling, no tricks, high-end cards still lead the way. They also handle heavy ray tracing way better, where AI can assist, but raw performance still carries a lot of the load. Competitive players chasing very high refresh rates can benefit too, especially in games where frame generation is not ideal. And outside of gaming, workloads like 3D rendering, video editing, and AI development still scale heavily with GPU horsepower. So high-end GPUs aren't going away, but their role is starting to shift a little bit. What makes this kind of shift different from past GPU trends is how fast AI features are improving. Every generation, upscaling looks cleaner, frame generation gets more stable, and latency keeps getting lower and lower. Game developers are also starting to design their games with these technologies in mind. This isn't just a bonus feature anymore, it's becoming part of how modern games are meant to run. So instead of performance being driven purely by bigger chips and higher power draw, we're moving toward performance driven by smarter rendering. In that kind of future, the GPU with the best AI tools might matter more than the one with the most raw horsepower. Of course, AI performance tricks are not perfect. Upscaling can introduce visual artifacts, especially in fine details or fast motion. Frame generation can also add latency, which is not ideal for competitive players. And native rendering will always be the cleanest, most accurate image. But most players are not pausing the game to compare screenshots at 400% zoom. They care about how the game feels when they're playing. And as AI keeps improving in GPUs, it improves the smoothness of the game without requiring massive jumps in hardware power. High-end graphic cards are not disappearing anytime soon, but for the first time, they might stop being necessary for high-resolution gaming the way that they used to be. So now I'm curious, would you rather spend more money and have perfect native resolution, or would you rather save a little bit of money and have higher frame rates powered by AI? If you enjoyed this kind of deeper dive into where PC hardware is heading, hit the like button so I know to make more videos like this. And subscribe if you want more smart PC building and performance breakdowns, especially as this AI stuff keeps evolving. Thank you for watching.